Welcome back to the generative VQA series. In the last video, we built the main VQA architecture, but a generative model cannot work without a proper vocabulary. We need a tokenizer, we need a mapping between words and IDs, and we need a decoder that can convert prediction back to text. So, in this video, we'll build a full vocabulary from the scratch. So, let's start the video. We start by importing all the required modules. So our first one is the pandas. We are going to use it to read our CSV file. Next is our counter. It helps us to count word frequencies. And the last one is word tokenize from the NLTK tokenizer. And it helps us in splitting text into meaningful tokens like words, numbers, and punctuation. So these are all the function and libraries which we need. Next, we're going to build our class called vocab, and this is going to our main class here. So first of all, we have self.vocab, which will store all the tokens. Then we have the vocab size, how many tokens do we have. Then after that, we have two dictionary. First is word to index, or basically token to index. So for each token we are going to give it an ID. So this would help us in converting that word to an index number. So we will give it a word and we would get our index number. And next one, index to word, would reverse this thing. Here the key would be index and it would gonna give our word back. So these would be used while encoding and decoding that text. Next, we have 4 special tokens. So these are an important part when you work with any generative thing in text, especially NLP. So first we have pad. So pad is used to fill empty spaces because the length of all the sequences should be same. So to make them same, we fill rest remaining with the self.pad ID. Next we have self.bos, so it indicate beginning of sentence. Third is self.eos, it indicate end of sentence. And the last one is unk, unknown, so it represent unknown word. So let's say during encoding we have, or decoding, we have some unknown word which we don't have in our self.vocab, so we're going to replace that with unk. So these special tokens are important, and the main are basically the EOS and BOS, because our GRU decoder needs these tokens to know where a sentence starts and where it ends, because we cannot use our decoder to generate a long sentence, because we need to stop at some point, and our GRU is really simple, so it cannot even generate too much long tokens, that too perfectly. So that's why we need these tokens. Next is our main function, that is build vocab. So this function create a full vocabulary from scratch, okay, using the answer in our data sets. So let me first stop it there. Okay, so we pass is the metadata data frame from this, what I'm talking this. I'm gonna read this and we're gonna pass this. So we're gonna use answers, all these answers, and we're gonna create our vocabulary. Okay, next, let me get to the next part of code where we count the words. How many words are there, building their frequencies, that is important. So what do? Here we loop through all the answers. Okay, then each answer first is lowered, then we use word dot tokenize to convert that answer into proper tokens, and then we update the counter with each token. So this would build give us word and its frequency, so that we can filter which word we need to keep based upon their frequencies. Next, we're gonna filter words by frequency. Okay, so here what do? We loop over the counter dot items. So this here is a for loop. So inside it, this would give us a word and its frequency. So we say if frequency is greater than or equal to minimum frequency, if it is greater than or equal to, then we're gonna keep that word. Then only we're gonna keep that word, else we are not going to keep that word. So with this way, we filter our words, that is our tokens, which we're gonna include based on a frequency. By default, its value is 1. You can increase it to 2 depending upon your need. So this minimum frequency, what it does, it basically reduce noise, and it also decrease the number of tokens or words you have, because the size of your vocab directly affect your training. Now we need to add special tokens into our vocab, because these special tokens are really important. So we're going to add them to our vocab. So here our total vocab would be, first we have those special tokens, then we have the rest of the words which we have taken from the answers, because this function would specially be used for answer decoding, answer encoding and decoding. For questions in our generative VQA, we are going to use GPT-2 tokenizer, and that is good for questions, but for answers it's not good, because the vocab size of GPT-2 is around 50k, and that is too much for us to train, and especially on a 1050 Ti 4GB. So I think and building our own. Now you remember we have these two dictionaries, that is word to index and index to word. Now what we're gonna do, we're gonna fill them up, because we have our vocab. So here we loop over. First we have word dot index. So we're gonna loop over them. First of all, this here for index word enumerate vocab. Okay, and then we're gonna fill this dictionary with word as the key and index as the value. Same we're gonna do for the index to word. Here we are going to use word to index the dictionary which we already have. From inside it, we're going to take the word and index and create a reverse of it, because this would be easier. You see, you can work with this alone, but every time you need to loop, so it's better you want to save them at some place, because the number of words are not that much. Okay, it won't going to take so much space that you need to think about it. So we have these two for our easiness. Okay, and also one main question is, why are we converting tokens into an integer? Remember, your deep learning always work with numbers, so we need to convert that text into a number. So this is one way. Okay, and this way works best. So let me do some update in this build vocab function. So here we are providing values to this self.vocab, then self.word to index, then index to word, then filling the self.vocab size. Then one more thing, we need to create something more, so that later we don't have an issue. So we are creating 4 more variables. First is pad token ID, then BOS token ID, then EOS, and then unknown, so that we can easily refer to them without looking up into the word to index, then giving that. So just so that we can easily refer to them. Our next function is encoder. So let me paste the entire code and then I'll explain you step by step. Okay, so this function basically takes a text and the max length of that text. Okay, we would not have the size greater than max length. So this function basically convert the text into a sequence of token ID. This is what we will feed into the GRU decoder during training. So first of all, we take that text, convert it to lowercase, and then we tokenizing it using the word tokenize function from the NLTK. We get a list of tokens. Okay, now we need to convert the words into IDs, those specific tokens. So what do? We loop over the tokens, this list, and we get the individual token from it. So here we use self.word to index this our dictionary, where here we give it the word, the token, and we get the value. By default, by mistake, if it does not have the token, it's gonna give us the unknown token ID. See now how easy it is to refer to that. Now we're gonna append it between the BOS and the EOS. So now our token ID start with BOS, then we have all the tokens, and then we have the EOS token ID. So this is how it would work. And at last, what we're gonna do? We're gonna pad or truncate. So remember, all sequences must have fixed length. So we either, first of all, we pad them or we truncate them. So this is how we're gonna maintain a fixed sequence, a fixed length. Our next would be decoder function. So this function basically convert the numeric representation back to a normal text, like a human readable text. So our key logic here is we can loop over all the token IDs, and if we encounter pad BOS, we're gonna skip them, and if we encounter EOS, we immediately stop, because EOS means end of sequence or end of sentence. Okay, let's go over. So we have all the tokens, an empty list. So we loop over all the token IDs. We have individual token ID. We're gonna check if it is EOS, break. If index is either pad ID or BOS, then don't go last, just continue the loop. We don't need to go next step. Now is the main. We take that index and we use index to word and get that token or the word, and if we don't have, we replace it with unknown, we get unknown. And at last we join all the tokens with a space in them. The main issue here is that you will see in the later is especially with the this punctuation mark. When you give it as an input, they are with the word, adjoining the word, but when you join them, there would be a space. So this is one issue. You can solve it yourself. So let me now give you the entire code for testing it. The codes are for function. This entire class is done. So this is one of the simplest implementation of the vocab, and here we have not built our own tokenizer. We are using from NLTK. We have built our own encoder, decoder. We have our own vocab list. We have word to index and index to word dictionary for reference. So here is our data path. Then we have CSV path. Then we have the length of answers. After that, we are reading our CSV file. Then here we are initializing our vocab. So first of all, we are building the vocab. We are giving it the metadata, and here we set minimum frequency 2. Then size of vocab. You can directly also call this vocab size. This is also nice. Okay, but let's do it this way. Like apart from this, you can make change into this code, but the basic core is this. This is the core of the program. It can be updated with more logics to make it more efficient. Okay, so first we're gonna print vocab size. So let's do it. Let me comment that thing out. Okay, so we have around 1.6 keywords. So let's say if I say frequency equals to 1. Okay, so let's see. Now we can see it's nearly doubled, 3.6 words. So see, nearly half of the words are appearing only one time. So I think we can remove them. So this is just a basis upon which you can filter your words. Maybe you sometimes feel that in your answer you do not need punctuation. You can also remove them. It's your choice. Okay. So this is one thing which you can add into this program. So now what we're gonna do, we're gonna take some, we get all the answers, sample answers, then this is answer at the index 0. Then first of all, we are going to encode it. We're going to give it the text, max answer length, max length basically. Then we decode this encoded representation. So we print all the thing at once. Okay, sample answer or text is white and purple. One of the simple text, no punctuation. So it start with 1, and you remember 1 is BOS, beginning of sentence. Then white is this is, and this is purple, and this is 2. So 2 refers to end of sentence, and 0 refer to padding. So now count it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has a fixed sequence length of size 10. And when we decode this encoded representation, we get white and purple text as back. So see, both the encoder and the decoder function is working. Now if I replace the simple text with something more, let's say with some punctuation, hello world. See, this is our encoded representation, and how we gonna get it back. See, hello world with punctuation, and even punctuation has their own things. See this comma. So first it start with 1, then it word with 3. So remember, this is unknown. This is the ID for unknown, because we have 4 special tokens. If you remember here, these 4. Yes, pad, boss, EOS. So this would be 0, 1, 2, and 3. So at last it is padded by 0, and when it return back, so hello is replaced by unknown, and you can see this space between unknown and comma, and same with world and this exclamation mark. So let's say now I want to increase the size of this. This is a test of encoder and decoder. Now I think it's long enough. It's more than 10 words, I think. Okay, now you can see long sentence, and if you see it start with 1 and it does not end with BOS. I think we should have BOS at the end, irrespective of its length. If its length is more than 10, we should keep 9, and then we can check that. I think this is also good. It's not that worry, because there's a data set which we are using has only a simple answer, so we don't need to worry about that. Now if we see the word back, unknown, comma, world, this is unknown, it does not have test, then it has off, then it does not have encoder. So it is taking representation up till this specific length, and it's converting it back. Maybe it does not have those words, so it's replacing those with, what do we say, this unknown. So let me increase our vocab size. Do we have something? We have increased our vocab size, but we still don't have more words. So let's back it to 2. Now here we can see one of the drawbacks of using word based tokens. Our tokens are word based. So the problem here is we cannot have all the words in our vocab, because they could be rare. Let's say in 10,000 answer, only one question, let's say in 10,000 question, only there's only one question which has an answer which represent a word, and that word is only appearing one time in 10,000. So how rare it is? We don't need that, because those kind of words which are very rare would be unnecessary, because they are not appearing many times. We can of course sacrifice that, and we're gonna have some performance issue also. But here remember, we are not building a generalized a representation of something. We just have a specific task, so we're gonna focus on that only. But if you're building something general, then I think your vocab size should be large, and I think you can include all the words, or maybe better thing is use sub word based tokens, that is BPE algorithm, byte pair encoding. So that is best, that is sub word based tokenizer, because it would represent both the things. Because now you can have word based tokenizer, or you can have character based, you can have two things. So a midway in the mid of both, like character based and word based tokenizer, you can have a sub word based tokenizer. So this is the best, but for now this task, this is good. So that's the end of the video. So I hope you learned something from it, and if you did, then please like, share and subscribe for more such informative videos. Thank you. Have a nice day.